This is the Amp Hour Podcast. Released June 16th, 2019. Episode 447. Voltnuts for flashlights.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Cough button at the ready.
Yes, wintertime sickness.
Yep. Sorry if my voice
you're not
is...
feeling well.
Yeah, if my voice is crap, above usual crap, you know why. No magic filter to fix that one, I'm afraid.
Has it been impacting you've been having any like spacey circuit diagrams that you've drawn out in like a sickness haze?
I actually decided to do pretty much nothing. I actually decided to just take the week off. So I pretty much haven't done anything for the whole week. Yeah, I think, last Thursday and it's Friday, following Friday now. So, yep. I only really got back into it yesterday and whole week.
I don't want to sound like an addict or anything like that, but like sometimes when I take cough medicine, like in the winter when I have a cold, and it's like a stimulant.
Right.
You're like, yeah, layout time. All right, let's do this. And then I look up and it's 12 hours later, and that's not good for your sickness. You're working yourself even harder because you've got all this effectively speed in your system.
Yep. Well, I don't take the drug. Well, I did in the end. I was told that I must take them. So
yeah.
But like for the first 4 days,
I think that's smart though to take to do like the hard break, be like I'm not going to work.
Yep.
And just rest it up and that kind of thing.
But that impacts your business, and if you think about technically the money it's worth, like it's a crap ton of money, right?
Right.
So if you think of it in those terms, especially when you work for yourself.
Well, yeah. How does it work in Australia? I mean, you guys have, I guess, like I always think about the benefits in the U.S. are always kind of crap in general.
Yep.
But when you work for yourself in the U.S., it doesn't really matter. You don't work, you don't get paid. There's no real difference there. So it's not like there's sick leave.
There's no sick leave.
Otherwise.
No sick leave in the U.S.
I mean, there's nothing required.
Oh, okay, right. No, here it's compulsory of all companies. I think everyone gets 15 days a year sick leave, but it's non-accumulative, so you can't accumulate the sick leave. Yeah.
Right. And so I knew that happened in like Europe and Australia and stuff like that. But how does that then work when you work for yourself?
It doesn't.
Is it
no. Okay. Well, I can pay myself.
Sure.
But it's like, it's.
Money's still coming out of the same bucket.
Yes, no. Technically, I'm an employee of my company, so therefore I do have to pay myself sick pay. But I could just pay myself anyway. It doesn't really, it makes no difference.
Right. If you took the day off and went to the beach, you could also pay yourself that day.
Yes, of course. I just
right. You're responsible to your corporation, which is you, and you're in charge of that kind of thing.
Yeah. It isn't like the money. It isn't like the government gives us money. So
of course,
it doesn't work like that. Yep.
Yeah.
But it forces the employer to pay their employees up to. I think it's, or is it? No, I don't know. I rarely took a sick day at work.
Oh really?
So it was the old sickie. It's un-Australian not to take a sickie.
I remember that one.
Chuck a sickie. Yep.
Yeah.
Very un-Australian if you don't chuck a sickie. And yep. Anyway, our Prime Minister at the time, when we beat your Yankee ass back in 83...
My Yankee ass?
Yes.
I was born in 83, Dave.
Oh, well, something like... I think it was 83, when we won the America's Cup for the first time.
Oh, I see.
You guys hadn't lost it for like 115 years or something, and these Aussies come along and win this America's Cup. It's only got America in the title, and we win it. And our Prime Minister, drunk off his face, on national TV that morning, got on and said, any boss who sacks anyone for not turning up to work today is a bum. And it's a famous line,
that's amazing.
Famous line from our Prime Minister, who holds, by the way, the world record for skull in the yard glass. So
you're saying words I don't. Is this like delirium that you're the sickness delirium?
Yeah. Well, I wasn't. Nobody's aware of the yard glass, and unless you're a real hardcore drinker, it's a glass that's a yard long. A yard is about a meter, you know.
And, I know what a yard is. That's actually how we measure things here.
Right. Right. There you go.
American football is yards.
Oh, okay. Yes, of course it is.
Yes, it's 39 inches to the...
Yep.
To the,
anyway, there's this giant flask glass thing, and he holds a world record for sculling that. That's the Australian Prime Minister. Well, former. He actually just died the other month. So
yeah, he just died.
Anyway, there you go. So we're into beer already.
Well, beyond the beer, what's been going on there?
Pure excitement.
Yeah.
Going internally berserk. It's so exciting. No,
what is the video you made about? I can't say I brought myself to watch them, about like the children's toy switches. What was up with that?
Oh, right. That was. What was the deal with that? Is that I was at home, like I wasn't supposed to be working, right? And Sagan said, "Oh, the toy's broken. All right, I'll have a look at it." And I don't have a lab at home. Like I don't have anything. Like I've got a screwdriver, right? I don't, like I can't solder anything. I can't do anything, right? And so I took the thing apart and discovered that the switch had melted inside the thing. This is a AA battery-powered thing. Melted. The switch had melted. Like it burned the board, melted the plastic case all around it. The lever, the switch, it's one of those slide lever switches that actually physically burnt off, melted out, and embedded itself in the plastic cap on the side of the case. So anyway, I thought that was so fascinating. I got the little compact camera out and just shot a quick video of it. And I thought, bugger it, I haven't, I'm sick. I haven't uploaded any content to my main channel. So I thought I'd chuck it on the main channel. And quite a few people complained that I didn't actually repair it because I didn't solder the new switch in.
No.
Oh, God, that's not the interesting part of the video. The interesting part is that how a AA battery-powered little infrared remote control toy can melt a switch.
Right.
And obviously,
was something like failed short or something, or what do you think happened?
It's failed short inside the switch. Either it's because they grounded the outside contacts of the switch. It's one of those metal covered through hole, old school slide switches.
It's like super cheap, like
super cheap,
stamp metal,
like stamp metal,
1 cent each.
Yeah, exactly. So it's either shorted out to the case internally, or it's shorted out as a make before break contact inside the switch. And one of those two options. Anyway, it's shorted out inside the switch, and the way they designed it, it was connected directly across the battery, right? So and AA batteries actually contain a lot of energy, even AAA batteries, right? Contain a ton of energy.
I'd love to talk about that. I've been doing a bunch of stuff with that, with battery stuff. So I'd love to talk about that in a second.
It's the even a little coin cell, even a CR2032 coin cell battery actually contains a lot of energy, but its ESR is like 20 ohms, right? So you short it out and it does nothing, right?
Right.
But if you extract all the energy out, dump it into a supercapacitor that's got practically zero ESR, then you can almost weld with that thing, right? With the energy that came out of that battery, right? If you can convert it to a more, usable form. I'm not going to say it's still more usable form into a
more readily available.
Yes, with a lower ESR, then you can do a lot of damage with just the energy inside.
You can pump it up and all that other stuff.
Yep. So it's just anyway, it shorted out the switch.
That's crazy. What do you think actually did that then? I mean, do you think something actually built up the charge and had it stored or something? I mean.
Huh? The charge is stored in the battery.
I know, but you don't think that there was an alternative? I don't remember. I didn't see the circuit, so maybe it was really simple.
Right. Well, the contacts inside the switch were connected directly to the battery, so they shorted out, and then literally shorted out the battery. So obviously that, and it wasn't zero, hence why it dissipated a lot of power inside that thing. So it might have been an ohm or something like that, for example. It didn't short out. If it's shorted out to nothing, then there's no power dissipation there, right? Then power dissipation's in the wires.
It turned it into a heater, you're saying?
It turned it into a heater. It was a resistor. And it dumped 3 volts across that poor little resistor, and it heated up, right?
Yep. Okay.
So 3 volts, V squared on R, right? So 3 volts on, say it's an ohm, there's 9 watts, right? There's 9 watts being potentially dissipated, not including the contact resistance and the wire resistance and everything else. There's potentially 9 watts being dissipated in that tiny little pissant switch.
Yep.
No wonder the poor thing melted,
Yeah.
So, yeah.
Never had a chance, man. Never had a chance.
No.
They don't make them like they used to, I guess, the little ray guns.
Anyway, so I made a follow-up video. I've got a segue. I got segues coming out my backside today. Okay.
Cold medicine.
Anyway, I did a second video a follow-up video where I actually soldered in the switch just to keep everyone happy, Anyway, well, I didn't solder. I desoldered it and jump at it. Anyway, I inserted some video into there, and I talked about DC arc over, right? Which a lot of people in the comments of the original video said, hey, what if, Huxley was sucking on the thing and there's saliva in there? Couldn't that cause it to, go low impedance, and then it heats up and then it triggers a thing? No, unfortunately, it doesn't work like that because the voltage is only 3 volts. So you're not going to get what's called DC arc over into the thing, which then sustains a plasma, like a carbonized plasma-y thing, right? I insert this. So if you've got a high enough voltage, say several hundred volts DC, it's got to be DC. That's hence why it's called DC arc over. And I insert a video where they got 4 solar panels, just regular solar panels. I think they're 40 volts each, or something like that, right? So about 160 volts. And they short them, right, with these cables. Don't try this at home, kiddies. And they get these massive arcs, right? These massive plasma arcs that just, like once you contact them, it burns, starts burning, flames start going everywhere, and you can pull them apart, and it sustains this arc, right?
Whoa.
So it's actually,
what's the voltage on the thing?
160 volts. Thereabouts, right? It's not much. It's not high.
Yeah, it's not like you'd expect like tens of thousands of volts to arc over. Stuff
That's
like
right.
That.
No. DC arc over. And this is why they've recalled like a dozen different brand DC isolator switches. This goes into a previous video I did for my home solar system, right? Where my DC isolator failed. It's an isolator switch, right? And it's designed to break the high voltage.
I saw that. It was like all like gunked up in the.
Yeah, it was all gunked up, and we're lucky that didn't catch on fire because it's so common. A lot of Australian homes have burned down because.
Whoa, really?
Yeah, seriously, because these things catch on fire. You get DC arc over inside these failed switches when you get moisture ingress into them, right? Because they're out in the weather, so they, when water gets in, like in mine, it corrodes everything, and then the DC arc over starts. Or you can get this in failed connectors, failed dodgy wiring, old wiring and stuff like that. And because here in Australia, we mostly put all our solar panels in series. My one's 430, 450 volts, right? DC. And that's the thing with DC is that it sustains that arc and sustains that fire, right? So whereas AC wouldn't do that because the current would go in the other direction and it'd automatically extinguish the arc, right? Each cycle. Right, so it doesn't have the same chance. So that's the difference between the real huge fire difference between DC and AC there. And so it's a real big deal. And but unfortunately that can only happen at the higher voltages. It can't happen at 3 volts in this particular case. But yeah. Anyway, I've got another segue if you'd like.
Sure, man. Yeah, you're on a roll.
I'm on a roll, which involves Lewis Rossman, a former guest on the show.
Yeah.
Everyone knows Lewis Rossman, right? He sent me an email the other day, and I might actually do a video on this. I might do it today after this, perhaps, if I'm feeling energetic enough. And it involves one of his recent videos, which we can link in, where he repairs Apple products, right? He repairs mostly Apple notebooks and things. Right, and one of the most common failures in them is water ingress. Right, spilled their coffee on there. They've got water or a glass of water or other fluids on the inside, which shall remain nameless. Inside the probably like through the keyboard and the hinges. I think Chris just got it, folks. And and he and apparently there's this common LCD connector inside that always fails, right, it always arcs over. Haha, there's the segue, right?
Yeah.
And he contacted me and said, hey, can you explain, somebody like 6 months ago, like it's been going on for ages, somebody left this comment. They used to work in the hardware engineering group at Apple, and they they explained the reason why this particular connector, I can include photos, by the way, why it always arcs over. I'll try and, can we just paste photos into a mumble box? Or is that...
I don't think so. No,
you don't know? Oh,
no.
Oh, what a shame. Okay, hang on. Here we go. Can I... Yep, there we go. I just sent it to you. There you go. Okay. A photo, right? So you know what I'm talking about. I think it should be, there we go, you should have it. And it's one of those, flat flex,
right.
high
the
speed,
one
of the press-in ones, right?
Yep.
And you see how it's got some large contacts at the end, right? Well, they actually hold the backlight voltage, which is about 52 volts. And you might think, oh, okay, it's only 52 volts. It's not hundreds and hundreds of volts, right? But 52 volts is enough for this thing to arc over. You can see all the arcing next to it, because right next to it is
like carbonized.
It's just carbonized, boom, Yeah. And that's arced over. And the moisture ingress has done that.
So you're saying a little bit of moisture has gotten through, and that initially causes the charge?
That initially
I'm a little confused about what actually...
Yep.
Okay, so it's kind of like a cascading effect, or what is it?
It's a cascading effect. It's a catalyst. So once it starts that breakdown, then the higher voltage, and it's got to have high current capability as well.
I was going to say, it's like a constant current source, because then as it drives, it'll keep driving up and up and up to get to that voltage. I mean, it's not going to break down the air just because it's DC or anything like that, right?
No, that's right. Okay. So you've got to have the catalyst there to begin with. This connector, I've actually pulled up the data sheet for it, and it is 60 volts rated, right? So that's spoiler alert for my video, sorry. And they've already, so they're designing within the margins, right? So everything's fine, right? So you're designing this product, and okay, it's 52 volt backlight voltage. We're choosing a 60 volt connector, everything's hunky-dory. But they obviously haven't given any thought to, and that voltage rating on a connector, by the way, if you don't know, is going to be due to the creepage distance, not clearance, but creepage. Right. There's a difference between creepage and clearance. I think we mentioned this the other week, didn't we? Clearance is an air gap.
We've definitely mentioned before.
Anyway,
yeah.
Anyway, when you use the word clearance in PCB and electrical, you're talking about an air gap. So if there's a physical air gap between two items, that is the electrical clearance. But if you're talking about a PCB or a connector which has two contacts on a surface, then obviously the surface, or the shape of the surface, it might have little grooves in there and cutouts or whatever it is, right? It follows that surface. So the creepage is that something traveling, is the arc traveling over. Right.
I think about it like an ant. Distance. If an ant was crawling.
If an ant was crawling, yes. Yeah. Yes, that's right.
And sometimes that is. Yep. It's never shorter than that, but it does need to be. It can be shorter if you're going around the edge. So you just said a PCB, right? If you think about going around the edge of a PCB, then that's going to be the shortest path, versus then the air is going to be, even if you were just above the PCB, you're going to be a little bit longer.
Yeah, exactly.
So it's geometry focused and stuff.
Yes, exactly. So it has to do with the topology of the thing. It has to do with the surface coating, which is why if you get out a good PCB calculator like the Saturn PCB toolkit, then you can actually calculate the creepage, or like the withstanding voltage that you can get between how close can you get two traces together, right, for a given voltage, right? That'll be the rating. And that will change depending upon whether you have solder mask or not. Because if you've got solder mask, then in theory, the moisture can't get under the solder mask, right? So there's no surface contaminants on there. That's one of the reasons that's one of the benefits of solder mask, is that it keeps contamination off your actual traces, right? So...
One of many benefits.
One of the many benefits. It's called solder mask for a reason because it's used for soldering. But one of the benefits is that it keeps contamination off your traces. So inside your product you get soot and dirt and crap build up and fluid. You might get moisture built in from its thermal cycling or used in different environments. Then that stays off the traces. So anyway, it's obviously gotten inside this. They've had spillage, and once it starts, then it arcs over and it forms like carbon traces. Once it does that initial current surge, then it starts converting that into carbon, right? And then of course that's low impedance, and then it starts and that's why you get all that charring, right, from the thing. So it's and it's only 52 volts. DC.
Yeah, it is a lot lower than I would have expected.
Exactly, right? You'd expect, there must be hundreds of volts on that connector or something. No, 52 volt backlight does all this damage. You have to see the photo for yourself. And it's as common as mud. Yep. He gets so many Apple notebooks in, and he knows by, without even taking apart, somebody spilled something in there, and it's the backlight voltages, right? And anyway, so the employee the former employee at Apple actually, let me call it up. It's easy to see, I'm quoting this person, which is Rainy Days on, they're just a random YouTube comment, but they claim to have worked at Apple. No single designer is responsible. So we're trying to find out who's the cause of the problem here. Is it the designer? Is it the PCB layout person? Is it, who is it? Right? So no single designer is responsible for the design from start to finish in a large corporation. The error started with the CAD librarian. And here's where, one of your favorite things, right? The error started with the CAD librarian who's responsible for drawing the schematic symbols for new parts and maintaining them in the library, who incorrectly labeled pins 1 and 43 to be far apart numerically when physically they are close together, with the mindset that the physically larger rail would be grouped together with the other rails without highlighting. So it's a numbering, and I can send the schematic through to you. But I won't do that now. Anyway, so he's thinking that it's probably and then the person who was designing the schematic pulled in that library and went, pins 1 and 43, they're physically far apart. I got no problems with pin 1 being the 52 volts and pin 43 being the ground or the other little low voltage differential signaling data line. No worries, right? And
right.
So whose fault is it there? Well, I contend that it is the schematic designer again, because if you actually have a look at the schematic, they've physically drawn the connector. Even though they're numbered weirdly, yes, 41 is next to 43 is next to pin 1, but they've physically grouped them to reflect the actual physical layout of the connector.
That's why I like doing it too, so you don't ever get confused by that kind of thing. It sometimes it's not practical, but I like that kind of thing if you can.
Yeah, I prefer to do it that way too. I like drawing physically how it looks. And it's always a debate, right? It's up to the schematic designer, or in this case, maybe the PCB librarian, or your company's standard, how you're actually going to lay out your schematic items. And things like these connectors, it really kind of is important to group them functionally, to actually draw them as they're functionally equivalent on the PCB. Because it helps you from a repair and troubleshooting point of view when you're debugging the design. Pin 20 is and you can physically see, especially with one of these type of connectors that has a different, a physical larger pin at one end and the other, then, it just makes it helps you orient mentally where these pins are and stuff like that. So it's drawn like that. So you got to say, well, the schematic designer knew, right? That
it's tough too when you're when you are
was next to it.
I mean, I guess have you ever been separate from the layout in your career?
Because
you did a lot of layout.
I was the company PCB layout person.
Right.
I've sat both sides of the fence. Yes, I've had to over. I've had to reluctantly hand over my designs to the PCB layout person. Yes.
Right.
Yeah.
I mean, it's tough when that happens because it's the best you can do is obviously you're going to look at the physical thing if you have it already. But say the librarians get backed up a lot of times too, and sometimes you don't have it. So you're kind of making these informations. I could see how that happens, and it just kind of gets kicked down the road, and you know, and then of course you're not going to spill water on it intentionally in the lab.
No, that's right.
It, so.
And so that's the thing. So really, it's not like I blame the electrical person, but they should. See, because Apple don't fix their own products, right? That's the thing. They don't get feedback from technicians saying why these things fail, because they're a board swap company. If you send it back to Apple, they don't actually repair individual parts. That's why it's so expensive, and that's why Lewis is in business, right? Is because he troubleshoots them down to individual parts. Apple just board swap. Right? They don't care. Sure. So I'd be surprised if they get any feedback at all from this common as mud fault that, people are spilling water in their notebooks or some other liquid in their notebooks, and it's causing it's causing an arc over on this high voltage pin. And Lewis says it's common as mud.
That might have been fixed already too, right? I mean, that's the other thing is that these designs are so decoupled. By the time as a consumer product hits market, they're already working on three products down the line.
Well, yeah, true. So what's the average span of an Apple product? 18 months tops, 15 months, something like that, right?
Before depends on the right. I'm sure that there's not a ton of rework, and it's even a new product when you start to cost down and that kind of thing for the future. It's in manufacturer's hands versus designer's hands, and so as a former person who is working on manufacturing style of things, I wasn't about to go start changing everything around, and be like, I'm going to reconfigure this connector. It's like you just do the best you can. Yeah.
So, but you think they would know about water ingress, and they'd probably have a design policy around water ingress, perhaps.
Maybe.
And because they physically don't have, even though they could have, I believe. I still haven't researched it thoroughly, but they could have left a couple of spare pins between there and not had the data and ground pins right next to the high voltage DC thing. But really, is that the fault of the designers though? They could have taken more margin there, perhaps.
You did say earlier, I'm not here to blame.
Oh, right, I'm not here. Well, it's here. I'm actually taking the blame off them somewhat. It's like how far do you go? Do you start putting in physical slots between 50-volt rails just in case moisture gets into the board in that particular part? It's a tough call, right?
Yeah,
how do you particularly blame a designer for that? They use the right rated connector, and they could have took a few more liberties, but anyway, it's a very interesting question.
Well, it sounds like you're gonna be doing more analysis. I'm sure we'll hopefully be able to link in the video by the time it's out, so that'll be good.
I might end up doing a deep dive video. We'll see.
Yeah, that'd be cool.
Yeah.
I want to go back to batteries. Can we go back to batteries?
Did we start with? Oh, yes, we did talk about batteries before.
We talked about batteries a little bit. I've been working with some battery stuff, and so I haven't done much with cells in the past. I've talked about lithium, and I've been doing a little bit more with lithium lately.
Yep.
But
what type of lithium? Lithium ion, lithium polymer?
Lithium ion. That was the 18650s that I was working on.
Ah, right. Okay. Yep.
Yeah. And we've talked about that was on the show. I can put that in here. But I've been doing stuff with some alkaline, just more consumer-y, replaceable stuff. And it's actually really interesting. The two projects I'm doing here was so disparate in terms of cost targets too. Cost targets were for the first one we're $250 or less, and it's fine. And this one's more $5 and less.
$5 or less.
Yeah,
for the whole
so it's
product.
Yeah, it's that mindset shift is significant.
It's huge. Yeah.
Yeah. And so, but I had been poking around a bunch with battery stuff, and I had happened upon some new cells, not new cells, definitely not new, but cells that I had never really heard of before, and maybe you had though, the CR123. Have you used those?
Yeah.
Yeah. So what are there pros and cons of using those things? I mean, I looked at them, and it seems like they're lithium mostly. I think they're all lithium, right?
They're lithium primaries. Yes, they're lithium primaries. They have massive energy density, and they're very common in torches. And CR123s used to be common in cameras back in the day. This is before digital cameras, right? Film cameras.
So they flash
that
stuff?
had flashes for flash and things like that, for charging up because you needed the ultra low ESR. And CR123s were very popular in old school film cameras. for that reason. And there's multiple, standards for little compact ones. Torches are a big deal these days. All the super 1,000 million mega lumen torches and stuff like that.
Put on
or your
a really
torch
fat LED on
aficionados.
it, that kind of thing.
Yep, all your torch aficionados are flashlight for you Yanks.
Yes, that's right.
And yep. That's that is a rabid fanboy rabbit hole. If you want to go down the torch go to any torch forum. Wow,
Right. You'd hold a torch for it. You're saying?
They're serious. Yeah. They're serious about their torches. Let me tell you. Yep.
Why is that?
And,
I guess it's like the knife collectors and the people that are like into different things. It's just like a collector thing.
Yeah, it's the same thing. They just, I think it's like, this one's like 2% better. So it gets that anal retentive crowd. I've got to have this new torch because it's got 2% more lumens and the beam width is slightly wider than this other one I've got. And they're just obsessed, and it weighs 2 grams less. It's a big deal. Yep. Okay. And they just love specs. I think they're spec driven.
So it's like test and measurement
obsessed.
folks, but like for flashlights.
It's Voltnuts for flashlights. Yeah.
Yeah.
Voltnuts, the people who obsess over 8.5 digit DMMs.
Yes, that's right. Yeah.
All day.
Okay.
Yes. Yeah. So it's fantastic.
Have you ever used one in a product though?
CR123s. No, I've used them in not commercial products. No, but I've used them in other sort of short run.
Short, yeah. Okay, yeah. I mean, it's nice. 3 volts, and it seems like they have I think the ones I was looking at were 1,500 milliamp hours on them and stuff like that. So it seemed like a nice little compact thing. It's just
You do realize you're not talking
they're not
proper
cool
units. You don't talk milliamp hours. You talk watt hours in batteries. Just saying.
You really?
Oh yeah. No, well, the only figure that matters is watt hours. You can't say milliamp hours
because things you're saying.
No, but milliamp hours, you're leaving out the voltage equation entirely. So you're not talking about energy, right? So you're talking.
I know. I can do that part in my head though. So I'm comparing.
But
I was comparing it to
3 volts.
2 AA's.
Yeah.
No, I said
you can use it.
3 volts. I know.
Yeah, but it doesn't stay 3 volts. And it's not precisely 3 volts. It's you would never survive on a torch forum. You'd be dead already.
On a torch forum? Yeah, you're right. Yeah.
Anyway, but if you want to do the engineering right, no, you specify battery packs in watt hours. And, I've done a lot of work in this area, and you do always have to talk in terms of watt hours. Nothing else matters, So anyway, that's how you have to qualify batteries and stuff like that. But you can compare same chemistry batteries in terms of milliamp hours if you want to. That's fine.
Right. Well, and I was looking at some comparison curves too, and really, so when you say watt hours, it's really kind of area under the curve kind of thing, right? Because it's, I guess that's not even, it's like energy, right? Yeah. So it's a full energy kind of summation over the whole.
Correct.
And I know some people like doing the that's always used as a good example of a data logger type thing, right?
Yeah, right.
They measure a battery as it drains and watch the current, watch the voltage, that kind of thing. Mm-hmm. So, but I'd never done one of those tests before. Right. Maybe in the future though. We'll see.
Okay. Cool. Anyway, so you're now suddenly fascinated by CR123 batteries.
Yeah, I'd never really heard of them before, so thought I'd pass on the never heard of, and I'm sure there's other people that have never heard of, but. A lot that have. So, it was interesting too. And apparently, quadruple A's are becoming more prevalent now because of a lot of the, you go online, a lot of people are complaining about they're in those pens. The stylus pens,
the tablet pens. Yeah, yep, that's right. Yeah. Yep.
So I was just kind of comparing all those things and looking at different. Watt-hour ratings, apparently.
Yeah.
Just trying to figure out, because, the real thing that I was looking at, too, is that, ultimately it comes down to a space constraint thing. And I found that I've been doing a lot of 3D modeling stuff at the very beginning of my designs, more than I ever used to. Because it used to be I'd be handed a shape, it's here's what you get, fit inside it, don't ask questions.
Yep.
And now it's projects I'm doing are much more open-ended, like, well, what's the best we can do? How do we optimize this and this and this and this? Optimize cost, all these other things. And so it's been more back and forth, and a lot of that is the space constraints and even what are the plastics going to look like and all that other stuff that I've personally never had to deal with. I mean, I think you guys were, for the microsupply, you knew you wanted to target a certain shape just for cost, and you were targeting the extrusion at first.
Yes, that's right. But then we switched to the two-part molded. Yep.
Yeah, and I think that's the thing. Like, so I think about like the constraints, and like, so the note that I read myself for this episode was like, can electronics folks be trusted to do a design on their own? We've complained on here before. I remember we've complained on here before about like being handed the mechanical piece. But like, if I'm asked to do an electronics design, it's going to be a square board with really sharp corners and some mounting holes on it.
Right.
And, and that's not right.
Oh, goodness.
Can we be trusted, Dave? I'm not sure.
That's our job. Come on. Of course we can be trusted.
Well, I'm just saying that I'm saying be trusted to do the best mechanical design, and that's where I think the answer is no. Like if. I think that at least I optimize for, like big square numbers and square boards and like very simple, and lots of space, right? Yeah. And but you get like a product designer. So like last week, Pete Belloc was on the show, and he was talking about, so he was an antenna designer at Apple, right? And he talked about like, no. You get the industrial design folks, they get first crack, and then everything is based on that.
Right,
and
of course. Because they're making consumer products, right? That there's a huge difference there.
Yeah, no, true. But I mean, let's use a microsupply again, right? You know that you want to have within a certain envelope, right? A certain size. You want it to be handheld. That implies a certain thing. Yep. You know that there's going to be certain power envelopes as well. Like all of these things are ultimately constraints that now I'm much more. What I'm saying is I'm much more forced now to place these on myself. And like sometimes they're obviously very application based, but I find myself I'm doing it to myself a lot more now.
Actually, this is very interesting here because in terms of trust, I almost didn't trust David to do this, right? Because he's the one because you know how he's like a 3D mechanical CAD person, right?
Exactly. He's an optimizer. He loves it,
and he loves doing 3D CAD stuff, but. And he came out and he said this one day, trust me, I'm a professional, I know what I'm doing. And I went, no, you're not you're not an industrial design CAD professional. Yes, I am. And no, you're not. Do you do it every day? Oh, but I've done plenty of designs. Well, no, you're not. Right? You're not, you're not a professional. You don't do it every day.
Like, when do you get that title though? Like when would you say?
I would say you wouldn't get it after just doing one or two projects, right? Even if they're successful and you've learnt a lot and you know 10 times more than what I do. That's great, but I still wouldn't classify you as a professional because you don't do it every single day in, day out.
Right.
That's your thing, right? You might be good at it.
It's almost like a question of like, would you call them up specifically for that one piece of knowledge, that alone? That's like when it's a professional.
Probably.
Like if you're going to hire them as a consultant for that one thing.
Yeah, probably. Right? And, sure, I trust David to do these things, but I just thought it was interesting that he used that terminology. Right, and he considers himself a 3D CAD professional, even though he's never.
I mean, like it's a huge part of workflow these days.
Well, it is a large part of the workflow, and you could argue that he is.
Yeah.
But to me, it's
it's always shades of gray and like where you are in the ecosystem kind of thing. That's interesting.
So point. It's fascinating. But obviously, I don't think he did a mechanical. No, he wasn't like an electromechanical degree or whatever. I think it was. Anyway, he's very good at it.
Sure. Yeah.
But whether or not he's in the same classes as other, in professional industrial designers that I've worked with, I would say definitely not. They just have a ton more experience doing that sort of stuff,
Yeah, there's that special something too. Like when you see when I see a design from like an ID person, and you're like, first off, I'm not sure that could actually be made.
Yeah.
But second off, that looks amazing.
Yeah, exactly.
You know, like when they have the eyes for that kind of thing, and like I think a lot of it is like, you know, humans and pattern matching, all that kind of stuff. Like they've seen design after design after design. Like, oh, well, this fillet usually looks the best, and you know, this kind of mold injection, you know, this kind of mold element is going to be okay here, and that kind of thing. And actually, like thinking about mechanical stuff.
Well, I've got an example of that. The front panel for my my high voltage probe, right? My HVP 70 high voltage probe, available at a discount on my store.
Mm-hmm.
You know, anyway,
oh, wow, shilling.
Anyway, it's a great probe. Anyway, I got a custom front panel, you know, like a stick-on, you know, front panel made for it. You know, it has the EV blog branding, the EV blog colors and everything else. And anyway, one of my viewers is a professional industrial designer in terms of like doing front panel layouts, and they just know everything. They know how to match the colors. They know what fonts work together. They know how to generate the correct files in the correct, you know, all the correct stuff that goes to the silkscreen designers. They know how the silk screens are manufactured in the various layers, and they know, you know, like they just know absolutely everything and produce this beautiful result. So I definitely use him again. Right, so he's my number one to call if I need another like a front panel thing, and then once again, David said, I can do front panels, you know, I can do. So he showed me some examples of sort of front panels he does. He was quite proud of, and they look just like the ones I draw, you know. They're good, right?
Yeah, you're right. It's like the special something. It's like that design eye, though. It's really tough to get.
It was hard to basically the best thing I can tell him is I'll know it when I see it. You know, it's one of those I'll know a good result when I see it. I can't explain what makes it special, but you know, and there was a big difference there.
You know, one of my old bosses, he had a recommendation. What was it called? I think it was called like Design for Hackers or something like that. So my old boss was like had really good design sensibility and stuff like that. And he'd recommended this book. Yeah, it's called Design for Hackers: Reverse Engineering Beauty. And it is I've read a decent chunk of it. But it's kind of like, how do you make things look a little bit better at a time? You know, like obviously you need to, you know, keep practicing, keep doing that kind of stuff. But
some people just have the flair for it. You know, the knack. Yes.
Yep.
Yes. So.
Yep.
But but that's the thing, right? With the one-man band being so multi-skilled these days, right? You know, like almost like anyone, and being, you know, the tools.
Specialization is for ants.
Yeah, and the tools are so readily available, and the processes are so cheap. How cheap is it to design your own LCD, your own front panel, your own 3D case, your own enclosure, everything, right? So it tempts the electronic designer, in the case of this podcast, right? It tempts us into taking on all these different roles. I think there's actually consequence of not doing some of it, though, right? It is that it's that delicate balance of. But then you risk thinking that, I've done that before and I'm an expert. I know how to design 3D cases, and then you come a gutser, right, on your next design because
once you hit well, or even if you take it so you like it works well enough, you 3D, like, so in my case I've done that. I've 3D printed it, whatever, got into a certain point, and then it's like, you know, you maybe even send it. So like there's like online services that allow you to do like even injection mold, like soft tool injection molding these days. And it's like, but you're going to get to a point and then it's going to be really expensive or not a good design, or, you know, like it's just, you're going to run into a place where that was not a good idea.
I've got a great example, a huge example of this.
Yeah. Okay.
Tesla. As some
wait, the car manufacturer, or the person?
the car manufacturer. Sorry, right? Tesla, they're hot in the news, right? They, you know, best cars on the planet supposedly, right? They're winning all these awards, blah 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 blah, right? But they're super expensive cars, right? They are not cheap, and these designers from, you know, these industrial designers, like car designers who know all about car design and manufacturing for cost and all that sort of stuff, took apart a Tesla, took apart every bolt, and they analysed it. Can't remember where the article is, And they went, this is why Teslas are so expensive. Look, they're using 5 bolts here when Toyota are only using 2, right? Because they've perfected. They know how, their designers know how to manufacture low-cost cars. The people at Tesla didn't. Right, and that's why their cars, and that's why they're having production problems, right? Because they can't get the volume and they can't get the cost
right
down
and the volume
on
then
their
drives
production.
like a manufacturing engineer to be like, why are there five screws here?
Why are there 5 screws here? And they went, oh, look at the shape of this panel. You don't make it shaped like this because it's X amount more expensive. It takes X amount more production time. Blah 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 blah. And if you were an experienced Toyota designer, you would know this.
Right, if your job is to just take cost out of a thing,
yes,
right?
Yeah, that's right. And they've been doing that for 50 years, right? That's been their job for 50 years, is taking, shaving cents off here and there, shaving seconds off the production line.
Yeah, but then it also then feeds forward, right? So then a good company like Toyota is going to then feed that forward and be like, hey, stop doing this crap. I don't want to redesign this later, right? So then they go to the design meetings and they start to push that forward. I think Tesla's just young, quote unquote young in the car market over time. If they keep growing, I think they'll
of course.
get there
too.
Of
course they'll figure it out. But, they may not get there because their share price is going down the toilet, right? And they're not making money and somebody's going to end up buying them, right? That's most likely end result. But anyway, that's a fascinating high. You can make a fantastic product, right? That is an absolute world beater.
The Juicero, it was a beautiful product.
The Tesla is the Juicero of automobiles.
No,
Chris Gamble said.
I didn't say it. You said it.
I'm going to put a photo of you with the thing.
I just said the Juicero was a beautifully built product, which it was. It was a beautiful product. It was just really stupid.
And the Tesla's not stupid. It's just not cost optimal.
Right.
And that may mean it might not survive in the market ultimately.
Right. Right. It's not
unless they
forgiving
can fix
place.
those things. Yeah.
Right.
So it's fascinating, and I'm sure they've got some of the best designers in the world there, right? And they know exactly what because it's like the safest car on the planet. It's like the fastest car on the planet. It's the best, everything.
It looks beautiful
on the planet. It looks fantastic. Everything about it's beautiful, except that they can't manufacture it cheaply.
Yeah.
Because that wasn't, I don't know, they didn't have enough people there experiencing that sort of, or maybe they did and they didn't have enough sway.
Time, whatever.
Yeah, they didn't have enough influence in the company. They might stick their hand up and go, hey, Toyota, do this for a reason. Just saying, we only need 2 bolts here instead of 4. This panel needs to be shaped this way. And, maybe they just didn't have enough voice within the company perhaps.
So when does this push back into your design? That's what I think about is like, okay, so we're talking about this stuff. We're talking about cost optimizing at the manufacturing piece, right? How do you pull that forward in the design piece? I think that's ultimately the goal, but I think that's really hard to do.
It's really hard to alert. I've had much experience in this over the years. It's really hard to alert people of potential. Well, it's really easy. It's easy to raise the alarm, but whether or not they take it seriously, they can go, look, guys, in 6 months' time, we're really going to have problems because we're not doing it this way. And it's really hard to articulate why you need to do it this way. Often you have to go, look, trust me. I've had experience in this before. And they'll go, no, don't worry about it. She'll be right. She'll be right, mate.
Right.
And,
I had an example of this. So I was, and it was just a simple thing of like choosing between surface mount and through-hole components, right? And just thinking about process steps. And obviously this is a very small example of this, but like surface mount versus through-hole components, like how that would end up impacting things. And like, so I was doing all these shuffling around when I was talking about battery stuff. But ultimately, like I know that if I have to do a selective solder process, it's going to be a lot lot expensive.
Can you explain to those at home what the selective solder process is?
Yeah, so selective solder process. So there's wave process. Actually, there's a link too. Scotty just went to a factory, Strange Parts. Scotty just went to the PCB wave factory. That was a good tour. And he showed a wave solder at the end. That was just like
a big wave.
Wave of molten solder. Yep. Selective solder is basically more like a squirt gun of molten solder, and then it basically kind of does an XY and it shows where it's going to be and stuff like that. And that's good for soldering through-hole components. However, then you have to like leave clearance around it, right? You can't put certain parts near it, or else, if you have a 603
there's got to be
resistor,
because it's a nozzle that comes up from the bottom of the board, right? So you put your through-hole component on the top, right? If you're wondering how an entire board can be surface mount, the whole thing, hundreds of BGAs, hundreds of other through, and then it has one through-hole connector on it, and you go, oh, geez, that's a pain in the ass. You've got to pass it through the wave.
Whole new process.
No, you don't. You sit on a frame, a little XY robot, little bubbly bath comes up, and it might be 5 millimeters in diameter, and it comes up and it solders each pin. It just goes boop, 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 boop.
Well, it's still a separate process, though, so that's still expensive. But it's not as expensive as making a shield. Because the other thing you can do is you can do a shield that covers up. It's basically like a solder mask, but for entire sections of the board.
Yep.
And you could put it through the wave, and the wave, it hits the metal there, and it doesn't go through there. But then some parts it does go through. And
anyway, folks at home, don't put your surface mount parts on the bottom of the board close to within 10 millimeters of your through-hole pins. Otherwise, they won't be able to get the selective head on there. Yeah, they won't be able to get the selective head, and they'll have to hand solder it.
Yeah, and then it gets real expensive. Right, and so think about that. So then basically it's almost then you have to put a keep out area, so it's okay, I know that I'm definitely have a through-hole component now. I have to use it. It's the only one that's going to work.
Sure.
And personally, usually that's when I'm well, does it really have to?
That's, no, but tangents,
but sometimes, sometimes it is, it's the only thing that's going to work. And it's okay, now there's keep out areas around there, and how is that going to impact other things? Thinking about the process and how that's going to pull back into the design phase, and then maybe it affects your spacing, it affects your bunch of things. So, so I don't know if there's other examples of pulling that manufacturing piece back. Like I always think about this with the Kickstarters of the world too, right? So they start from a certain point. By the time they're talking to a manufacturer, it's I have to redo the entire board now. It's that's not gonna, I'm out of money, I'm out of whatever.
Right.
That's so talking to a manufacturing person early is usually a better case, and then you can kind of pull that back into the design cycle if you can. I don't know if there's other examples of that that you have off the top of your head though.
No, but it's a fascinating topic. So anyway.
Yeah.
We've only got 5 minutes left. We need to cover the big news.
Oh, yeah.
Of the week.
Yeah. Make is gone.
Make is gone. Make magazine, make a fair.
Pour one out for your homies.
What?
No,
Pour one out for your home? No.
You never rap culture?
No, sorry. No, you're gonna have to explain.
Dave, not rap culture. When someone dies, you pour out a little bit of liquor on the ground. You say, pour one out for my homie.
No, sorry. No, it's too street for me. Sorry.
Yeah. Right. That's what I represent on the show.
Yankee
Chris is from
Street.
Chicago.
Right. Okay.
Mean streets of Chicago.
Yeah, right.
I apologize. Anyways.
All right. Yeah, they gone. They shut up overnight. But apparently this was not... It was announced by the CEO that... Well, hinted by the CEO in recent months that, hey, look, this might be the last Maker Faire, look, we're really struggling to make money.
Yeah, it sucks.
So
and, I know a bunch of people that work there, and I like them all. They're all good folks. It sucks. Hopefully they're fine and hitting the ground with their running, landing on their feet, I guess.
Yep.
So they're good writers, but I think generally it's just so it's an event company and a publishing company, and those two things are tough. Publishing, especially, obviously.
Yeah. Well, the magazine, they had 125,000 subscribers to the magazine. So you've got to think, well, how did the magazine not make money? Because the likes of Silicon Chip, right? They have an audience 10 times, 1/10 of that, and they are able to run at a profit. So you got to think that the magazine,
that's always what it comes down
it's
to.
the other overhead, because it was all under the one barrel, right? So, you had the events, you had the magazines, you had the whatever it was.
Right, and the thing you really want to talk about is that they also took VC. So let's just
took venture capital.
They took
$10 million at that we know about, right?
Yeah.
Way back at the start. And you got to come on. I mean, you got to think, right? VC people are looking for a 10 times return, right?
Sure. Yeah.
That's ballpark. That's what they're looking for. They might take a 5 times return, right? Heck, if everything's failing, they'll want to get their money back, right? So when when you accept $10 million in venture capital, they want to exit at some point with $100 million. Right, so that $100 million either has to come from profit, from operating profit. Usually not, but in theory, if the company was to just if they were to pull out and you had no other investors, they would want their $100 million, right? So you're not going to get that in operating profit from a Make magazine thing, right?
I mean, it's a low, both are low margin business. They have high costs, they have high people count, they have high physical
high
count of distributions, and for the magazine
tons of things.
Paper magazine has distribution costs, everything else, and then advertising just sucks.
It's not a
terrible thing.
And then you're reliant upon advertisers and sponsors and things like that, which can pull out and ebbs and flows of that happening. I'm used to that myself, advertisers coming and going. And it's a fickle business to be in, right? So the only way they were going... So I'd say it was either destined to... Well, you've got to say it was... Well, no, I'd argue it was doomed from the start when they took that VC money.
No,
right?
maybe.
Because
I don't know.
They could have kept the dream going longer and then offloaded and then sold it to another investment sucker, right? And then the original investors, yay, we bailed out, right? They jumped ship.
Right.
That's what they're looking for. They're either looking to go public or they're looking for an exit strategy. Right, so they're looking for one of those. So they could have made their money, but ultimately, you said it right. The company, it's a low margin business, right?
It's tough. I mean, it's real tough.
I
have now officially run one event, a small event, 200 people, and goddamn, that was tough.
Did it make money? Did you at least break even?
Broke even. I had a little bit of money. Yeah,
kind of right.
Yeah, I was the employee, so. And then so the other thing that I think about is, I mean, the top level sponsors they've had for the past couple of years, at the fair at least, you're right. It's just a tough business. They're asking for hundreds of thousands of dollars effectively for top level billing, and then and then what are they getting out of it? They're getting a bunch of it's not like this is not like an industrial kind of conference where you're getting access to certain people. You're basically doing a general public event, and it's targeted, and I think it's a lot of goodwill.
There's no visible return.
There's not ROI, right, exactly. So how are you gonna convince your company to keep doing that year after year? And that's really that's a tough sell, I think. So all around, the thing that always weirded me out is that there was a couple years in a row where the top billing company, they died the next year. So it was Radio Shack was in 1 year, and then it was Barnes and Noble was 1 year.
Right, yeah, of course.
And then I was every year I was looking at who's the top. I'm who's gonna kick it this year? I'm oh no, Arrow, don't do it. Arrow. Sorry, no. Google, you don't do it. They're both fine. They're both fine.
Right.
But Radio Shack specifically, it's where the hell did Radio Shack get money for that kind of thing?
Right.
Where did they get money for anything? Honestly?
You've always got money until the doors close, right? And
there's always money in the banana stand,
right? And that's the thing. So was it? Does anyone agree with me that it was this market? I'm sorry, it was just doomed to failure. Once they took that venture capital. Money, they couldn't just operate it as, even if it was making money, right? They couldn't operate as a successful business because the VCs want their money back, right? So,
sure, I don't know how that works. Even if they want their money back, how does that? Is it calling a loan? Is that kind of how that works, or what?
I don't know. They put in a new CEO. No, they're always going to push the limits, right? They're going to sack the CEO, right? Because they have control to do that, and they're going to put in a new one who then will then try to on-sell it to someone else, right? Because there's only 2 exit strategies. There's technically 3, as I said. When you're an investor, one is to go public. Right, and then I'm a shareholder, you can sell your shares and that's how you exit. The other one is to get another investor to buy in at a later stage. Woohoo, I'm out now. Somebody else bought the shares. Run. Right, you've got your money. And the third one is to go, well, look, nobody's going to buy this company, but it's and we can't go public, but it's profitable, so let's just extract the money out of the profits, right? And then just leave.
Yeah.
But there's, of course, it's not profitable enough, right? It might be profitable, and it might have been a profitable business. We just don't know. And we suspect it wasn't. But even if it was like, well, the investors are going to want to leave, right? They're going to want their money back. It's been 10 years or something more, right? It's been more than that. And they just
2007 started, so 12 years.
So I suspect it, like up until the last minute, they were looking for new investment income, and nobody was going to be part of it. No, nobody wanted a bar of it. So, and then they just folded overnight. So
yeah, it's too bad. It's it's like well, I did appreciate all of the kind of retrospectives people did. Evil Mad Scientist Labs did a really good one. We'll share that here. Jeff, buddy Mighty Ohm, Jeff Kaiser did one as well.
Okay, didn't see that.
Yeah, it's on his blog. There's a picture of a very, very young Jeff Kaiser on there. It's
right, okay.
Yeah, it's fun.
Cool. I never did get to go to a real Maker Faire. Obviously, I only got to go to the mini Maker Faire. Yeah, I had offers, but it's like. But
right,
everyone was telling me in the last couple of last 4 or 5 years, it's the same every year. Like people just gave up going. They said they gave up going.
I may have said that as well. Yeah.
Yep.
Yeah.
I think you have said that on the show. Yeah.
Yeah, it's tough. I mean, like it's a lot of the. The reason to go is the same reason that I go to every event is not for the stuff, it's for the
catch
people.
Up with the people. Yep.
Right.
You catch up with them again. Yeah.
That's what I always promote that people do at any event. I just had a meetup, what's today? 2 nights ago. And it's starting to become the same crowd that comes to the hardware happy hours here. But it's like, you catch up with the people, but then it's also, I think the big thing is like encouraging people to bring that next project, work towards that next thing, like have something else to talk about. If it's just like a casual catch-up chat, it's like, well, that's less compelling in getting people to come back because like, I think that events kind of atrophy in that way. You have to keep doing interesting things. You have to have interesting and hopefully that brings in new people and that kind of thing as well. So
right. So there's no more future for fairs. It's just meetups.
I think they said they still might do minis. They might still. That's kind of all. I think they're figuring that out, like what who owns the IP and like what is the future of the licensing agreement and stuff like that.
Right.
So
because with the Maker Faire, it's all about the branding, right?
Sure.
I know that the Sydney Maker Faire, they did it as a mini Maker Faire, official branded Maker Faire one year, and suddenly the next year it wasn't a Maker Faire anymore. It was
really?
just
okay.
They said, I talked to them about it and they said, no, there was too much red tape. There was just so much, crap hoops they wanted us to jump through to make it a mini Maker Faire. And it was we just couldn't be bothered. So we just ran it as a Maker Faire. Oh, sorry, as I don't know what they called it.
Science fair or something like that.
Something like that, yeah exactly.
Yeah. Is there any, so I saw there's a thing that I completely missed actually, but Infineon is buying Cypress. I don't know if that actually matters to us at all here.
Does it? No.
I mean, Infineon's mostly automotive, right? That's like a big thing that they do.
They do tons of stuff, but yeah, I think so.
I think of them mostly as automotive, but they're in a bunch of markets. Cypress, I can't really say. I mean, like I know Cypress makes the PSOC. That's about the only thing that I know about with them. I think they do one of those one of those USB chips as well. But that's like it's like thinking about like, does this affect me? No, not right now. It may be in the future, but if people don't know, that just happened. So.
Oh well, it's going to happen or something.
It's going to. Agrees to buy. It's going to be a year before they. Yeah, it's interesting too. Like all the people I know, a past heartbreaking purchase of Linear Tech now being gone. I keep watching all the LinkedIn profiles; they're all different now.
Right. Yeah.
So, but honestly, it hasn't really impacted that much. So that's a positive. Not that I would have asked for it to happen again, but it hasn't seemed to change too much. Maybe internally there's some changes happening, but so that's good. Mm-hmm. There's a hope for acquisitions yet.
we just gave up at one stage actually reporting on market consolidation. It's been a bit quiet recently.
It has. I think because money started getting more expensive. I think
money's getting right. It was getting
Yeah. So borrowing, and so there's less like. There was definitely a lot less like privatization that it was happening. Like that was happening like like towards the beginning of the amp hour, like a lot of things were being taken private, like NXP formerly, I guess, no, sorry, Freescale, then whatever they are now. Yeah, they were private, and then they went back public, and a couple others went that way too, I think. So, but like that stuff's kind of like, at the end of the day, like, what do we care as the electronics people? We care about, like, can I talk to an applications engineer? Can I get the board? Can I get the parts? That's all that really matters to us. Like the name on it.
Exactly. Yeah. It's like,
it'll be interesting to see. Like, so one last thing. RISC-V got some backing as well. Sci-Fi is one of the companies doing it. So again, RISC-V is the architecture, the ISA, and Sci-Fi is the company. Is one of the companies that's using that architecture to then build chips of their design that then conform to that architecture. These are the things I've learned. They've created an open hardware group too, but basically they got invested in as well. And so it's going to be interesting, I think, with the whole. I'm still very interested in RISC-V about like is this open architecture going to like spin up more small companies, right? So that's the thing that we don't see anymore is small chip shops, you know. But now with like open architectures and obviously fabless semiconductor manufacturing, it is at least possible. Maybe not likely, but it is possible, and it'll be interesting to see if that continues to trend up. So that's all the Wonka tree I can handle right now, Dave.
And because that used to be like a thing. There used to be like several like sort of little boutique processors around the Rabbit 2000 processor.
Oh, yeah, we talked about that before.
Like just and there was the Parallax. Of course, they manufactured their own, designed and manufactured their own processor and stuff like that. Is that making it, a bit of a comeback, or nobody's going to bother? Everyone's going to go, RISC-V, like.
Yeah, I don't know. I think at a certain point we're going to hit some limitations on so if you can't squeeze parts any closer together on the board, you where else can you go? It's like, well, you could start to make either custom logic in an FPGA or custom logic in an ASIC, and I think at that point there is competitive advantage there. I think the tools are still, pretty closed up. So at least from my outside opinion, I'm very excited, of course, about the open toolchain stuff. I just got my Icebreaker, former guest of the show, Peter. I got an early bird Icebreaker board with the Ice 40, so I'm going to try out the FPGA toolchain stuff finally. I'm very excited about that.
Excellent.
Yeah. And I will be, next week I will be at Teardown. So if anyone's there, come say hi. I'll be seeing Peter and Alvaro, who are on-site recording helpers. I'll be recording with them, hopefully. And then just found out Jeff Kaiser is going to be there, too. So a little Mighty Ohm action.
Yes, sir.
Yes, sir.
That does look like a fairly good event. So
Yeah, definitely. Very excited about that. So,
and it makes me cry that there's nothing like that here,
You're going to have to start it, man. Sorry.
I'm going to have to start it. Yeah, I know.
Yep. Or, get on a plane for many, many hours. Your choice.
No, I'm thinking about it.
Okay. Yeah, think about SuperCon in November. It's LA.
No. I'm thinking about starting one here.
Oh, okay.
Like, it's just like, like I need another thing to do. You know? Like, I don't know.
Well, you do it. I'll give more consideration to fly down there than you'd probably fly up here.
They're right, yeah. Boy. Yep. Well, I do have an employee. I guess I can task him with it.
Sure.
Go and make a show happen. Yeah. Come back erect man.
Yep.
Anyway.
All right, man. Well, don't beat David up too hard there.
No. All right.
All right. See you next week.
Catch you next time.
Yep.